Hello geeks, welcome to my YouTube channel. In this video, we would be discussing a problem called largest element in an array. So the problem states we are given an array of size n. We need to find the largest element in an array. So let's go back to the iPad and discuss it. So let's look at the example. Here we are given an example array of size n. Okay, our task is to find the largest element that is present in the given array. If you look at this array, the largest element is 150, and therefore I need to return this 150 as my answer. If you look at the example 2, the largest number that is present in this array is 900. Therefore, we need to return this as our answer. Okay. So the first approach that comes to my mind after seeing this problem is, what I do is I will sort the given array. Okay. So after sorting it, my array would be looking something like 30, 60, 80, 80, 100 and 150. Okay, since the given array is sorted in an increasing order, so whatever the largest element that I want, that would be available at the end of the array, that is at the last index of the given array. Okay, so if I return this last index element, my task would be done. If you look at the pseudocode, the first step we are doing is we are sorting the given array. Since we have given a vectors, we are sorting it. So this is the syntax to sort a vector. And after sorting the vector or the given array, I am returning the last indexed element. Since we know that the indexing of an array starts from 0 and the last element has an index of n-1. Since we need to return the last element, that is n-1th indexed element. So we are returning this n-1th element, and we are returning this n-1th element. If you look at this line of code, this takes me a big O of n log n of time, and since we are returning the last element, this takes a big O of 1. Time complexity of this approach would be big O of n log n, assuming we are using a merge sort algorithm to sort the given array, and big O of 1 to return the last index element, which means this is actually equivalent to a big O of n log. The time complexity is big O of n log. Can we optimize this? Yes, we can optimize this approach. In the next approach, I can think of a solution where I can maintain a variable which will keep the track of the largest element that has encountered till now. So this largest variable will have a value of the first element initialized initially. Okay. And then what I do is I would start the traversing from the first index and compare it with the largest value that I have already stored. Is 30 actually greater than 100? No, it is not. So I would be moving to the next index. In the second index, I have element 150. Is 150 greater than 100? Yes, it is. So what I do is I just update the value of my largest variable with the 150, and I would move to the next index. In the next index, I have a value of 80. Is 80 greater than 150? No. So I would be moving forward without changing my largest value. Okay. Now the element at index 4 is 60. Is 60 greater than 150? No, it is not. So I won't be updating this and moving forward. Since we are done with the array traversal, what I do is I would be returning this largest value. So whatever the value is there, I would be returning it. Now let's go back to the coding platform and try to write the code for this problem. As you can see, I have opened this problem. I have opened this problem in the coding platform, and the link for this problem will be available in the description. From there, you can actually go to this platform and can solve it. So as we know that we are given actually a vector as well as the size of the given array. So the first step, what I would be doing is I would be declaring a variable called largest, which would be initialized with the first element of an array. Okay. And now the next step I would be doing is I would be traversing from first index to the last index, and if by chance I am encountering any element which is actually greater than my largest element, what I would be doing is I would be updating the largest element with my current element. Okay. And at last I would be returning the largest element. So if I go and run this program, my bad, actually I didn't added here updation condition, that's updation and I express. So if you look at this, all the test cases have passed, and let's submit it. You can see that this code has been accepted, and this here, it shows a graph of the time complexity. Now let's understand the time complex. We actually traversed, we started from here, we actually traversed the whole array. That means it was a big O of n. Okay, we traversed the array and actually compared it with the tracked value, and at the last I returned the tracked value. That is the largest value that we have encountered till now. So that means we have took a time complexity of big O of n. And speaking about the space complexity, we didn't use any extra space to solve this particular problem. That means the space complexity to solve this particular problem was a big O of n, a big O of 1 soil. That's all for this video, guys. We'll meet in the next video. Until then, goodbye.